So here's a demand curve. We haven't even done supply and demand yet. We'll just start with demand. It's a Hicksian demand curve. My notation here, little p stands for the price of this good whose quantity we're graphing horizontally. And then big P stands for other prices of other goods people might buy outside this market. And U is the utility level or scale variable. And we're going to look at some areas here. And probably before we get too much into talking about areas, we should think about, well, what are the units of area in this picture? If I drew a circle and I measured its area, I would get a number, but what would be the units?
$dollars.
Dollars? Whatever units prices are measured in, could be euros or something else. We'll have some other units that aren't any currency. But whatever the units of prices, in the numerator prices, so prices are dollars per widget, then we multiply by the number of widgets, we would have dollars, right? Okay, I've put in two prices here, a baseline price, if you will, M, and we're going to call that price equate that price with the marginal cost, which is going to be constant. So we do have, now we have kind of a supply curve here in green. And the other price we're going to look at is M plus, and I'm going to call it a tax at rate T per unit. So think of the consumer having to pay M to the producer and also having to pay T in a tax. And then I've shown the corresponding quantities at points A and B. So once I've drawn this, there's a number of different areas we could look at. I'm going to start by looking at I like to call it the horizontal area, the area to the left of the Hicksian demand curve between the two prices. So what's the economic interpretation of that? This is something we do typically in the second week of price theory.
Is that the sum of tax revenue and the rate loss of the tax?
We will. You're getting ahead. Even if we didn't have a tax here, which had P1 and P2, what would this horizontal area be? Well, I did start today saying we would talk about the cost function. I haven't mentioned the cost function yet. Are we getting close? What's the relationship between the demand curve and the cost function?
It's the partial with respect to the input price.
The price derivatives of the cost function are the demand levels, right? Yes, so this distance is a partial derivative of the cost function. That distance is another partial derivative. So, and I could draw other horizontal lines in the red area that would also be partial derivatives of the cost function. So what does that make the red area?
Cost function between, like the cost and good to go from price and plus.
Right, a difference in cost. If you like calculus, it's an integral under the cost function between two prices. Under is a little bit deceiving here. Maybe we blame Marshall because the price is on the vertical axis. That's why it's a horizontal area. We're going between two prices, integrating from, say, the low price to the high price, and we're getting a difference in cost. And so I'm using C here for the cost function. There's a cost at the high price, there's a cost at the low price, and the difference is the area. Now, I referred to calculus, which many people who don't know economics know calculus. That's fine. But as an economist, we can bound this. Also, a calculus person can bound this. If you've heard of the rooftop, I believe they call it the rooftop theorem or the rooftop formula. An algebra expert could bound it, but an economist would bound it by saying, well, how much cost do I save from having this lower price, or how much extra cost do I incur by having the higher price? Well, when the higher price comes in, I have the option, I'm allowed to continue consuming at B. And if I did that, I know what would cost me. This is the type of Murphy derivation Murphy did, more looking at the cost function itself rather than its derivative. So there's a rectangular area here that I know has to be bigger or at best equal to that change in cost. And then I can bound it below by the other rectangle. We know that, well, at the higher price, I'm paying a tax equal to the smaller rectangle, and at least I have that cost, and maybe more. So that's the bounding we can get in this picture. I've already mentioned, well, this rectangle is the tax cost, because the height of the rectangle is the tax rate, and the base is the quantity purchased when that tax is being paid. So that's the tax cost. And you can see that we have some cost beyond that, and that is what we call the excess burden.